So we were discussing about function overriding. Function override, the advantages of using function overriding is polymorphism, code reusability. Function overriding allows the derived classes to reuse the functionality provided by their base class, reducing the code duplication. Dynamic binding, function calls are resolved at runtime based on the actual type of object. So during runtime, which object we created, through which object we are calling, enabling dynamic binding and facilitating runtime polymorphism. So the runtime polymorphism is achieved using function overriding. We are already discussed compile time polymorphism is through function overloading and operator overloading. Runtime polymorphism is achieved through virtual functions and by using function overriding and dynamic binding concept. So the disadvantages of function overriding is it increases the complexity of your program because overriding can make the code more complex, and especially in larger projects with multiple levels of inheritance, leading to potential confusion and maintenance challenges. And the performance overhead, dynamic dispatching of overridden functions can introduce a single slight performance of overhead compared to static binding, as it requires runtime resolution of the function calls. So it may lead to runtime while executing during compilation time, you won't get any error. But while executing or running the program, that time you may come across runtime errors. And potential for errors, if not used carefully, function overriding can lead to unintended behavior such as accidentally hiding a base class function or introducing a inconsistency in the class hierarchy. So the function overriding may accidentally hide the base class because the derived classes are always overriding the base class or the parent class. It make the base class functions not executed. It will always, whenever we call the function, always the derived class functions will be executed. It will not allow the base class function to execute, or it will sometimes it may hide, or it may make us to forget there is no base class like that, because always the derived class functions are doing the task. So it may cause potential errors, or it may cause inconsistency. Consistency may not be maintained properly. So they are the major drawbacks of function overriding. Say, for example, we are taking to understand the concept of function overriding, we are taking a class called the class shape. Here, we are making the base class function. Here in the shape class, we have a function called area. Here we are calculating the area of the shape, any general, and we have a derived class called rectangle. It is derived from the base class shape. It's having the function called area again here. In base class, we have the function area, and in the derived class, we have the function area. Our base class is called shape. It's a one function called calculating area of the shape. We have the derived class called rectangle. It is derived from base class shape. Here also we have one function called area. It overrides the base class function. Here also our class name is area. Here also we have the class called area. Here it will just, if it is in the shape class, it will display the message calculating the area of the shape. When this particular function is called, it will display the message calculating the area of the rectangle, and it will return length into width. And the same way, we have one more in the main program. We are creating an during runtime, we are creating the object called shape. using pointer new rectangle object. So when we create the rectangular object, the values of 5 and 3 will be assigned to length and width. So this particular function will be executed. Again, if we are calling shape of area, this particular function we are calling, because it is, we are accessing it through the pointer member access operator arrow, and here it will display the area of the rectangle. Rectangle area function will be called, and it will delete because we already created the object new shape. So we are deleting the object which is created using new, and the same way we are deleting, we have created the object called, here we created the new object rectangle. That object we are deleting using delete operator. So any doubt? We have the base class and derived class. In base class, we have the class called area. And in derived class also, we have the function called area. This to make the naming conflict and to avoid the overriding complexities, we are making the base class function area as virtual. So it is a virtual function. It will not create any objects and it will not be executed. Logically, it will be used. Physically, it will not be used. In the main program, we are creating an object of shape, where shape is our base class. This object is created using new operator, and we are using the class name shape, and a shape type. A new object is created using call by dynamically, and a rectangle type. We are creating rectangle pointer rectangle new of the constructor rectangle function is called. So it will pass the arguments for length and breadth, and the function from area is called, and the rectangle is called. And the objects which are created using new operator, new shape and new rectangle, both are deleted using corresponding delete operator. Here we are using additional function called virtual function that reduces our complexity. So we are making the base class function area as virtual. So it will act as a virtual function. It will allow the derived class function to execute. So polymorphism, it is a concept in object-oriented programming. It allows objects of different classes to be treated as objects of a common superclass, and it represents different understanding forms, data types. In C++, polymorphism is achieved mainly through inheritance and virtual functions, facilitating flexibility and reusability in code. The main advantage of polymorphism is it allows the programmers to create as many functions with this duplicate names, and this code is reused in base class and derived classes through reusability. And how we can understand the polymorphism means compile time polymorphism is achieved through a function overloading and operator overloading, and runtime polymorphism is achieved through inheritance, virtual functions, where the functions can be executed. Execution is determined during runtime, because we are creating the objects using new and delete operator during runtime. So runtime polymorphism is implemented using inheritance and by using virtual functions. A base class declared as virtual function, and the derived classes overrides that function. If you make the base class function as virtual function, it means we are allowing the derived class function to override. So it won't, we are making it as virtual. Logically it is exist, physically it won't perform any task. Providing their own implementation where a base class pointer or a reference points to references of a derived class object, and a virtual function is called. Say for example, method overriding is achieved at runtime. It is a redefinition of base class function in the derived class with the same return type as the and same parameters, while method overloading is achieved at compile time. Method overloading and operator overloading is achieved through compile time polymorphism, and function overriding or method overriding and virtual functions are attained through dynamic binding, or runtime polymorphism. So function overriding with the same name and same parameters and same return type defined in base class and derived classes. When derived class objects calls the function, it calls the overridden function in the derived class. So when we call the function in the main program, we are making the overridden classes in the derived classes will be executed, and the base class functions are act as the virtual function. When the base class objects calls the function, it calls the base class copy of the function. It means the base class functions are retired. Say function overriding, here we are taking the base class, it's having the display function, and we have the derived class. It is derived from base class. Here also we have the display function. In the main program, we are calling base class b dot display, we are calling the function. Now the object b belongs to base class. Then we call the function b dot display. It's supposed to execute the base class display function. But what it will do, the base class definition is called output IM. So this will display the IM base. And we call a derived class D. So we are calling D dot display. So the derived class function is called, derived class function is called, it will display the message I am derived. So here function overriding. Already, as we saw already, class animal, class cat from animal, class dog from animal, all three classes, animal sound, animal sound, animal sound. So depending upon the object, the corresponding function will be, say if it is a dog, my dog dot animal sound, it will display the cat, the dog says this, the bow bow. Say if you say and the animal sound, my cat, class my cat dot animal sound, it will call the corresponding animal sound, the cat meow meow. So the runtime polymorphism definition, the ability of the objects of different derived classes to respond differently when the same virtual function is called through the base class, pointer or reference. The decision of the on which function to call is made during runtime based on the actual object. The purpose is it enables flexible and dynamic behavior based on objects and type and during runtime. In function overriding, when a derived class inherits a virtual function from the base class, it can provide its own implementation to replace the base class behavior. This is called function overriding. So what is the purpose of overriding means? It allows the derived classes to specialize on or modify functionality inherited from the base class while maintaining a common interface. So the syntax is class, derived class, access specifier public, abstract base class. And within that, we have the public and private sections. Say to make the base class, we'll make it as abstract base class. So we are creating a class called derived class. It is derived from base class. And if you make your base class as abstract, pure base class, then the overriding can easily happen. And if you make the to avoid pure virtual function, that overrides implementation code for the derived code. So we are converting the base class as abstract base class, and we are making the function as pure virtual function. So semantics, when a virtual function is called through the base class pointer or reference, the compiler determines the actual object type at the runtime, and it calls appropriate implementation from the derived class. This is called binding. So during runtime only, until runtime, we don't know which function is going to be executed. So during runtime only, depending upon the type of object, the object will be mapped with the mapped or binded with the corresponding function. Say if the object belongs to cat, no, the cat class function will be executed. If the object belongs to dog, means the dog class function will be called. So the dog object and the dog class function will be binded. So runtime only the binding happens. That is called late binding or dynamic binding. Here, to understand the concept of function overriding and late binding, virtual classes and abstract base class concept, we are taking a class called shape, and the shape class draw function is made as virtual, and we have the derived class called circle. It is derived from shape. Here we are making the function draw. Here the draw, base class function is virtual draw class, and in the derived class function draw is overriding class, overriding pure virtual function. So your base class is virtual function, so it won't execute, and you are making the derived class function as pure overriding function. And we have one more class called square. So base class shape, derived class circle, derived class shape. This is square function also overriding function. The main program through pointer, we are base class shape type pointer we are creating. Circular class object is created. Square class object is created. And through the object, the shape class takes the address of circle, and through the object we are calling the function shape dot draw. So it executes a runtime polymorphism because we are using the pointer as well as we are using the pointer member access operator hyphen arrow. The same way shape equal to address of square. Through the object shape, the we are calling the draw function. So this will call the corresponding square shape draw function. Here it will call the circle class draw function. So we are using virtual keyword. We are making the base class function as virtual, pure virtual function. And we are making the derived class functions as overriding function. So keyword virtual is used, function keyword override is used. Say the shape class is abstract due to pure virtual function. So the definition of abstract base class is the base classes which are having pure virtual functions are called abstract base classes. So that is the definition of abstract base class. So what is abstract base class means? Already I gave an example. The base class which acts purely as a base class, it won't initialize any object, or it is used to execute the functions of other derived classes. Or we can say the base class which is having pure virtual functions are called abstract base classes. So the class is abstract when it is having abstract, when it is having pure virtual function. Circle and square inherit from shape, and the base class pointer shape can hold objects of derived classes, and through the pointer member access operator shape underscore arrow mark we are calling the functions. The program demonstrate the concept of abstract base class and pure virtual function. So the above program is example for abstract base class and pure virtual function, runtime polymorphism and function overriding. So they are all the keywords and concepts you should remember. You should know what is abstract base class. The base class which is purely used for creating other classes is called abstract base class. And or we can say the base class which is having pure virtual function is also called abstract base class. Pure virtual function means the object of objects, the function will not be executed in the main program, and it will be used to override, it can be overridden by the derived class functions. And runtime polymorphism means we will create pointers, and the objects will be initialized using new and delete operator during runtime in the main program, and the binding of object with the corresponding member function will be done during runtime. So if the object is belongs to cat, the cat display sound will be executed. If the object is belongs to dog, the dog object will be mapped or binded with dog class display sound function. And overriding means the derived class functions overrides the base class functions. It means when the same function is declared and defined in base class as well as in the derived class functions, always the derived class functions are executed by overriding the base class functions. Say polymorphism uses those methods to perform different tasks. For example, we think the base class called animal that has a method called animal sound. Derived class of animals could be cat, dog, birds. They can also have their own implementation called animal sound. So another example, a class called car, another class called specialized class called sports car. It is derived from base class car. So in base class car also we have change gear, and in the sports car also we have the change gear function. In base class, car can have gear, changing gears. It may be 2 gears, 3 gears, but in the sports car, it can have more than maximum 5 gears. 1, 2, 3, 4, 5, reverse, and more than that. And in the main program, we are creating an object of sports car where sports car is your derived class. The object is called sports car SC, and through the object SC, we are calling the change gear function. So we are calling the function object SC dot change gear of 4. So it will execute the function. If the gear of 4, the value of 4 will be assigned to gear. 4 is greater than 5. The condition will be checked. Then it will execute the gear plus plus. Any doubt in this program? We have base class car, derived class called sports car. In both the function classes, we have change in gear. In base class car, the gear, just the gear is implemented. Initially gear is 0, then it is incremented to 1. And in case of sports car, it can have more than 5 gears. And in the main program, we are creating initializing on object and we are calling the function. Here also, always the base class function will not be executed. It will execute. The derived class function will be executed. So any doubt so far? We discussed constraints of multiple inheritance, constructors and destructors in inheritance, and function overriding, abstract base class. Any doubt so far? So our next topic is called runtime polymorphism. So runtime polymorphism is achieved through virtual functions. Say here we are taking a class called class D, and we have another class called class D. The class D is derived from base class B. In a base class also we have the function called show and display. Here also we have the function called show and display. And we want to implement the virtual function, that is example for runtime polymorphism as well as function overriding. So we are bringing the virtual function concept. So the keyword virtual is mentioned before the base class function show. So in the main program, class B, object B is created and a pointer object is created through the point because we are using virtual function and runtime polymorphism. So we are using dynamic binding. So the objects are created dynamically during runtime using pointers. So these pointer objects stores the address of the actual object, and we are calling the function ptr equal to address of B, and through the ptr we are calling display function. So this will call the display function from the derived class, where the ptr is belongs to the derived class base class B. Again we are creating one more object called derived class D, object D, ptr equal to address of D. So through that we are creating class D is your derived class, and the derived class object is assigned to the pointer, and through the pointer we are calling the program. So we have base class B and derived class D, and in the main program, we are creating class B object B and pointer object class B star PTR, and through the address of object B is assigned to pointer variable. Through the pointer variable, dynamically we are calling pointer member access operator. Hyphen arrow. Hyphen arrow is pointer member access operator. Through that, we are calling the display function of base class. That is display function as well as show function. The same way, class D is your derived class, and object D is created. PTR equal to address of D. The address of object is assigned to pointer. So the pointer is having the address of the particular object. Through the address hyphen arrow member access operator, we are calling the function display and show. So it means your base class function show is virtual function. So it means when we call this function, it will automatically, it is a pure virtual function because we made the base class function as virtual. So it is an abstract base class. So it will always execute the derived class functions. So the benefits of polymorphism is, it is a runtime polymorphism or dynamic binding, enables single interface for different data types, allows reuse of code through inheritance and using virtual functions. It allows extensibility, makes it easy to add new classes without modifying the existing classes. It is the ability to use interface based programming. Interface by leveraging the inheritance and virtual functions, developers can write more flexible, reusable, and maintainable code. The examples provide in illustrate, and polymorphism facilitates the use of common interface with the objects of different classes, underlying the power of flexibility in object-oriented programming. So the major benefits of polymorphism: runtime polymorphism, using virtual functions and virtual functions and abstract base classes. It provides flexibility, reusability, and extensibility because the objects are created during runtime using new and delete operator. Pointers are used. So we are doing the process in terms of address. And until runtime, we don't know which function will be executed. Based on the object, the binding of object and its corresponding function will be done. So that is called dynamic binding. The same way we have class B, class D, and we have a word, say the same function, show function, display function, showing the base class, displaying the base class. We have the derived class, displaying the derived class, showing the derived class. In the main program, P points to the base class, P points to the derived class. The same program with the modified version. So what the output it will display? So initially, the pointer points to the base class, displaying the base class because the object is belongs to base class. In the derived class, the object is belongs to derived class. So it will display the displaying the base class and showing the derived class. As we discussed, the polymorphism is of two types: compile time polymorphism and runtime polymorphism. And compile time polymorphism, we have function overriding and operator overriding. Runtime polymorphism, we have virtual functions. So what is runtime polymorphism means? Runtime polymorphism is also called dynamic binding or dynamic polymorphism, where it gets resolved into runtime. One common example is runtime polymorphism is called method overriding. So method overriding or function overriding, and using virtual functions, we can attain the runtime polymorphism. So any doubt so far? Any doubt so far? Polymorphism, function overriding, virtual functions, and method overriding. So we were using the keyword virtual function. Then what is virtual function means? It is a member function. We will use the keyword virtual in base class and in the overridden in the derived classes. So if you make the include the keyword virtual in the base class, it means the base class function become virtual. It will allow the derived class to override the base class. If objects of base class invoke virtual function, then copy of the base class is invoked. And if derived classes objects invokes, then copy of the derived class is invoked. So it means depending upon the object through which we are calling the function, the respective function will be called during runtime using dynamic binding. Virtual functions are declared to specify late binding. If you want to bind the object with the function during runtime, not in compilation time, then we will go for virtual functions. When a base class pointer points at a derived class, the C++ determines which copy to be called depending upon the type of the object at runtime. They are resolved at runtime, not at compilation time. So until compilation time, we won't map the object with the function. During runtime only, the objects will be mapped with the function because the new operator will be executed during runtime only. Compilation time, it won't do anything. Say for example, we are taking class X and class Y. X is base class, Y is a derived class. We have the function called f in base class as well as in the derived class. Here we are not using the keyword virtual, but in case of virtual function, we are using the keyword virtual. When we execute the function without non-virtual and virtual functions, so here object of base class a dot f, so it will display the x value, and b dot f, it will display the y value. Again, if you use the pointer p dot f, it will display the x value. Again, it will display the x value. But in case of if you use a virtual keyword in front of the function, and if you make the function in the base class as virtual by adding the extra keyword virtual in the base class function, so depending upon the object, the objects will be executed. But if you use the make the base class function as virtual, it will act as a virtual function. And when we execute the objects through the pointers, here star p equal to address of a, p points f means the object a belongs to x, so it will display x. Again, x the object of x is initialized, and the pointer takes the address of b, where b belongs to derived class y. When we call the, because the address is accessed, the content of address p equal to address of b is object b, so it will display y. Here you can easily understand the difference between the virtual function and non-virtual function when it is used in dynamic binding. So any doubt in this? The meeting will end in another 5 minutes. I will take the attendance from the Zoom class recordings. Only there are 71 students now. Previously it was around 87 students. Any doubt? Virtual function and non-virtual function, dynamic binding and pure virtual functions. So this pure virtual function and abstract base class we'll discuss in the next class. So any doubt? Virtual function and non-virtual function? Okay, go through the topics. If you have any doubt, ask me in the next class.
Okay, ma'am.
The meeting will end in another 2 minutes. I will take the attendance from the Zoom recordings, Zoom recording attendance. And yesterday I given you an group activity. So that is a tutorial. So those who submitted, they will get the marks. Those who not submitted, they will not get the marks. Any doubts so far?
No, ma'am.
Okay, go through the topics. If you have any doubt, ask me in the next class. Okay, we'll end the class. The class meeting will automatically end in another 1 minute.
Thank you, ma'am.
Okay, thank you all. So while coming to the next class, go through the, I have already shared with you two textbooks. From the textbook, whatever, what are the programs they have given, just to go through it and write two
Okay,
more,
ma'am.
two programs based on two programs based on virtual functions, two programs based on function overriding, and two programs based on dynamic binding or runtime polymorphism. Okay, how to, when you come on Monday or Tuesday class, you should have two programs based on function overriding, two programs based on virtual functions, two programs based on runtime polymorphism, dynamic binding.
Okay, ma'am. Ma'am, may we leave the class?
Yes, you can, the meeting will automatically end. You can leave the class.